It's a Formula One legend, an English engineering powerhouse, and a high-tech supercar manufacturer rolled into one.
McLaren is a throwback to a time where race car companies would start to sell cars to the public.
With the electric automotive era upon us, McLaren must enter the future by reimagining their highest volume car and their entire vehicle architecture.
Represents a new chapter in the history of McLaren Automotive.
To do it, they'll need to engineer a new carbon fiber chassis, design a hybrid with their first production V6 combustion engine, and craft a cutting-edge electrical system in order to build a greener ultimate supercar. It launches from 0 to 60 in just 3 seconds, produces 671 horsepower, and hits a 205 mile/hour top speed. The McLaren Artura, a hybrid supercar built to enter an electrified future. But can the marque successfully make the leap?
The Artura is the first car to come from an entirely new platform and architecture, so that's a new chapter.
When the European Union announces plans to end the sale of fossil fuel-based cars by 2035, McLaren has no choice but to electrify its lineup.
We're seeing this incredible transformation.
The end of the world is coming for the internal combustion engine.
The end of the combustion era is coming, so brands like McLaren must reinvent their vehicles or possibly perish.
This is much more than a single car, it is a new architecture and a new platform.
In order to pave a path towards an electric future, McLaren must overcome 3 obstacles in order to bring the Artura to life. First, the marque must design a new carbon fiber monocell chassis. Then engineer their latest hybrid propulsion system. And finally, devise a cutting-edge electrical system. Yet, will it be enough to secure McLaren's place in a new electrified era?
There's going to be an upheaval. There will be a switching of the order. Everything will change. The question just is, how does it all shake out?
It's a bold challenge to define the next generation of supercars. Get it wrong and your marque might well fade away, making the Artura quite possibly a make-or-break car for McLaren.
It's not surprising in that McLaren's hand is being pushed. They don't have a choice at this point.
It is very much early days. This is just the beginning of quite a radical shift, and being part of that is a great task.
A great task that now falls to one of the most legendary names in motoring, McLaren. For more than half a century, the brand has found glory on the track. Yet remarkably, the company has only been building road-going production supercars for just over a decade.
We are the new kids on the block. We're 10 years old as an automotive company. Our competitors who are decades old.
The marque has quickly raced to the top, but can they continue to run at the front of the pack?
Traditional car makers have 50 or 100 years of we do things a certain way. But in an ever-changing industry, that tends to lead to a lot of problems.
The marque's very first serialized production vehicle comes in 2011. The MP4 12C.
12C was super successful.
McLaren's first road car was a part number. It was MP4-12C, which sort of violates the rule of supercars of, like, let's make it sexy.
The 12C breaks new ground for a production supercar thanks to its Formula One-inspired carbon fiber monocell, or vehicle chassis. A monocell describes an exterior shell that carries the structural loads through its skin.
12C was a competitor to the entry-level Ferraris. It was made out of carbon fiber and certainly looked like the future.
Looking like the future and staying relevant in the future are two very different things. The carbon fiber chassis that underpins the 12C becomes the basis for all the Marque's subsequent models.
Every road car that we've gone into production with has been built around a carbon fiber monocell.
The big, dark, dirty secret at McLaren is they figured out how to take one tub, one structural member, and make a whole lineup of cars out of it.
The carbon fiber chassis stays in production for 10 years. But a decade in the supercar space is an eternity. The time has come for the Marque to reimagine the underpinnings of its entire lineup.
The Artura has our latest generation of carbon architecture compared to our previous architecture is lighter, stiffer and stronger.
A more advanced monocell offers the Marque the opportunity to enter the electric age without losing its high-performance edge. The Artura is the first car to use the McLaren carbon lightweight architecture.
It represents a new chapter in the history of McLaren Automotive and represents the first car to come off an all-new vehicle architecture, the McLaren carbon lightweight architecture.
McLaren says this tub is an all-new clean sheet design. The good thing is they've learned from the previous tub and are able to integrate all of these improvements. And the risk is that that last tub lasted a decade. Any errors in this tub will be carried forward for the next 10 years.
The new carbon fiber tub shares nothing with the cars that have come before it.
The car started around how would we evolve, or in this case, evolve in design, lightweight, and manufacturing, the tub.
Evolution is a force of nature, yet sometimes it requires a subtle high-tech push. Welcome to McLaren's Material Science Laboratory.
We are in my secret lab.
Ella Podmore is one of the McLaren engineers tasked with perfecting the right carbon fiber mixture for the Artura.
What we have here is a carbon fiber sample. The idea is to check that all these plies are behaving the way that we want it to.
Ella and the team advance the art of carbon fiber, one very thin strand at a time.
Carbon fiber is just a catch-all term for a material that is a resin, a plastic basically, that's impregnated with strands of carbon.
Carbon fiber blends strong filaments that are often thinner than a human hair with a resin to create a composite material that's 5 times stronger than steel and twice as stiff.
Carbon fibers may look like thread, but when you combine that unidirectional strength in like a resin system, what you have is a really, really strong material that is high strength weight to weight ratio.
The carbon fibers add strength in a specific direction, but not every direction. And that's key. Engineers are able to tailor the material to their exact needs.
When you manufacture carbon fiber, you are orientating those plies yourself. You can directly put where you want force to go. You can directly put where you want areas with more resin and higher fiber concentration. And it's that bespoke way of manufacturing that we've been able to come up with something incredibly strong, very lightweight, but also to encompass everything that's new in our cars.
Years of hard work culminate in the use of 4 new kinds of carbon fiber. The result is a car that's 10% lighter than the Marque's previous vehicles. Shaving kilos means you're shaving seconds where it matters most.
We're getting the latest, most up-to-date and research-heavy McLaren carbon fiber lightweight architecture on the Arturas.
The desire to cut weight has been a core part of the McLaren story. Yet lightness alone isn't enough. To take the next step towards an electrified future, the Mark also needs to rethink the very heart of its car. Supercars are often super thanks to their high horsepower. Yet the dawn of EV tech and the EU-mandated need to lower CO2 emissions is forcing car manufacturers like McLaren to rethink the very future of their vehicles, right down to their competition.
It's one thing to say McLaren can compete with Ferrari on the racetrack. It's something else to say McLaren can compete with Ferrari in road cars, supercars.
The Artura is the Mark's latest attempt to do battle. An old-school mid-engine supercar that features a very new-school hybrid powertrain. That's been built for a single purpose: to blaze a trail towards an electrified future.
Artura is McLaren's new entry-level supercar. This is their most accessible model.
The Artura represents the Mark's first high-volume hybrid supercar. Yet its importance extends far beyond the car itself.
It has a breathtaking breadth of ability, and it's just going to set the stage for the next generation of new supercars.
So if you do it right in the first place, it has a long life.
To ensure that McLaren heads down the correct path, engineers must now figure out what will power their new vehicle.
Some of the things that have defined what a brand stood for are all going to change.
For the past 10 years, the company has been producing different variants of the same V8 combustion engine.
McLaren's problem was, we have to do one last engine. What's it going to be? Well, then go for the gold. All new layout, reduce cylinder count, get some of that efficiency, and then throw a hybrid on there for more power.
When the project begins, engineers are asked to create a more efficient engine in order to meet new European Union CO2 emissions regulations.
Artura was required to have a much lower CO2. The challenge that the team had was to deliver a hybrid system that had a range, but at no loss.
Engineers need to create a car with two personalities. It needs to be able to drive silently through a village, yet still be capable of ripping off 200-mile-per-hour runs.
Being right next door to the Formula One team can be extremely beneficial for us.
McLaren's F1 team has a lot of hybrid experience. In 2014, Formula One mandates that every F1 car uses hybrid tech. Nearly a decade later, that knowledge helps redefine the Mark's powertrain team.
We renamed our powertrain department to be propulsion, to strongly signal that it is an integration now of the electric drive team with the internal combustion engine team.
The propulsion unit's first order of business is to design a new combustion engine.
The engine was designed by our team in-house, and some of those guys were ex-Formula One race engine designers.
Engineers come up with a bold plan to hitch the company's future to a clean sheet design V6 engine. However, testing it requires a sleight of hand and an old van.
McVan, which as an ex-Ford guy, that was quite amusing for me. The first V6 and powertrain that we ever ran was actually in the back of a Ford Transit van. We cut the whole back rear axle out and we installed the powertrain, and engineers climbed all over it and it ran around the proving ground with nobody having any idea what was inside.
What's inside is both greener and also highly unusual. a 120-degree V-angled engine.
McLaren has come out with a 120-degree V6, and that's something that we've never seen before in production cars.
The main benefit of having such a wide angle is the ability to keep the engine very compact, particularly in length.
V6 engines want to be splayed out with the pistons at 120 degrees to each other. Car companies haven't prioritized that in the past, but when you're dealing with supercars, balance is really important and weight distribution is really important.
The 120-degree layout cranks out a massive 671 horsepower. Yet an explosive combustion engine is just one part of the equation when you're building a new hybrid supercar. For over a decade, McLaren has raced to the head of the sports car scene by crafting lightweight, high-performance-focused cars. Yet now engineers must rethink hybrid tech with the introduction of the Artura.
In the supercar world, we have to be very mindful. With the state of the world, we have to continue to innovate. We need to look at hybridization and electrification.
While their highest volume vehicles have been petrol-based, this is not the company's first dance with hybrid technology.
We had the P1 back in 2013 that was our first hybrid powertrain.
McLaren is a racing car company that has a road car division. The idea of hybrid power recovery in Formula One has been around for quite some time, so McLaren was quite early to the game with the P1.
The P1 costs nearly £1 million and offers just over 900 horsepower, thanks to the combination of a battle-tested V8 and an electric motor.
The P1 established that McLaren could not only compete with Ferrari on a racetrack, but also on the road.
After the P1, the marque continues pursuing hybrid tech. 7 years later, in 2020, they drop the Speedtail. It's an aerodynamically tuned Hyper GT that's the fastest McLaren in a straight line, hitting a 250 miles per hour speed.
What's unique about the Speedtail is not only did it have this central driving position, but it also was a hybrid car.
Both the P1 and the Speedtail allow the marque to hone its hybrid knowledge as it prepares to move into EV tech.
The realization that hybridization can bring such a performance benefit was obvious to us.
While the performance benefits are obvious, the size required to do it is remarkably small.
We've got our all-new electric motor. It's about this wide in terms of diameter. It's about this thick in terms of depth. And it's just over 15 kilos. So if you think 95 PS of power from something which is just as light as 15 kilos, it's incredibly impressive.
The new e-motor works thanks to magnets and electricity.
If you go back to your sort of basic science lessons at school, and you had two magnets. If you hold them one way, they will attract to each other. If you change the direction, so you feel a force. So it's capturing that effect in an electric motor that can convert energy from electricity into movement.
Powering the e-motor requires an advanced battery that weighs just 88 kilograms.
It's a battery unit that sits very low in the car, behind the driver and passenger, and below the fuel tank, and it has a usable capacity of 7.4 kilowatt hours.
7.4 kilowatt hours is roughly the same amount of power as the average UK home uses in a day.
We all need to learn an entire new lexicon of terms. You don't have a problem understanding how large the fuel tank is in your car. It's X amount of liters, X amount of gallons, no problem. Batteries are the same way, except they're measured in capacity. So a 10 kilowatt hour battery can supply 10 kilowatts for 1 hour. or 1 kilowatt for 10 hours.
The electrification of the supercar requires new vocab. Yet McLaren is well versed in the language of speed.
Currently, we are in a little hidden area in McLaren Technology Centre we call the Spine. So it's a little secret area where we have a few more little gems hidden away.
Cars that have battled for glory at the highest level of motorsport, Formula One.
McLaren, of course, has an incredibly rich history, around 60 years of performance on the track.
We've really got to tip our hat to our history, our heritage, racing. Really started with our founder, Bruce McLaren.
Bruce McLaren is a New Zealander who finds fame 10,000 miles away from home in England. In 1959, he becomes the youngest Grand Prix race winner at the time in F1 history.
Mathematically, you would never have considered or even thought that. But this was what Bruce McLaren was all about. He had a dream, and he certainly wanted to follow it.
Bruce's Formula One ambitions flourish. By 1963, his success on the track leads to his very own F1 team. 5 years later, in 1968, the company wins its first Grand Prix victory, and it never looks back. Today, McLaren has notched over 180 Grand Prix races and 20 World Championships. Stunning success that sadly Bruce McLaren never sees.
We lost Bruce McLaren on the 2nd June 1970 whilst he was testing.
The passing forever changes the marque's destiny, yet even Bruce would be hard-pressed to imagine just how advanced his namesake company has become. In 2004, the marque opens the McLaren Technology Centre.
Super impressive facility. I think deliberately designed to look a bit like a sort of Bond villain layer.
The state-of-the-art facility is where engineers are trying to figure out how to power the Artura's new hybrid propulsion system.
This is a car that is existing in a new world of computerization.
It's a new world of tech that now needs an electrical architecture to power it. To do that, engineers utilize a common bit of home computing.
This electrical architecture that underpins the running of the car. We have an industry first. It's an Ethernet-based system.
The advantages of a domain Ethernet-based electrical system are hefty.
In the past, you would typically have multiple ECUs around the car, maybe 10, maybe 15 different ECUs. What we've done in the Artura is move to 4 main domain controllers.
Fewer ECUs or electrical controller units equals less weight. The new network reduces cabling by 25%. Yet its true impact might not be felt for years.
As we move in the future towards cars that can drive themselves, they need redundancy. So we're seeing a huge emphasis on networking in the car to make sure that no matter what, every part of the car can talk to the others.
Having different parts of the car talk to one another helps set the stage for the future. However, for McLaren to really move the needle, they'll also need a stunning exterior. The introduction of electrified supercars offers new propulsion possibilities. Yet brands like McLaren must also rethink the look and feel of their vehicles, including the new Artura.
Understand, explore, and create. So in the beginning, understand the task, understand the problems to solve, and understand the vision.
McLaren must harness knowledge gleaned from their previous hybrid cars and craft a more accessible version.
All the electrified supercars that you normally have in the market tend to be quite high up, like the P1, for example. Artura was really distilling McLaren automotive design values into a singular product.
A unique product that must merge form and function in one enticing package.
I'm a designer, but I don't want a great-looking car that doesn't perform well. Form follows function, but form also needs to tell a story.
Goran Osbolt is the man tasked with creating a captivating visual narrative. His job is to help the marque transition to a new age without losing its sporting style.
Every time you start off a new product, it's always somewhat different, which is kind of part of why we love being here, I suppose. When it comes to Artura specifically, the task really was to set up a new and electrified supercar.
Crafting a new electrified supercar begins inside the design department.
We tend to have a general sort of vision for where we believe McLaren design should move towards in the future.
Yeah, so like we look at the search for the core line, maybe on the body side.
Every time we do a project, I want to achieve three things. Car looks like as if it's coming from the future. I would like it to introduce an innovative way of guiding air. And if in addition to that, we find new ways of cutting weight out of the product, if those three are integrated in a car, as they are in Artura, that's a McLaren.
Finding that future begins in a very traditional way, with a pen and a piece of paper.
When you start to explore, usually that's a doodle and a more sophisticated sketch model. You need to fail fast. You need to explore things and identify different routes, but you have a deadline that's always constantly approaching, right?
As the pressure mounts, so do the challenges.
The more the project grows, the more sophisticated the problems become.
Perhaps the most sophisticated problem is how to properly channel air around the car. The Artura's technical layout places the new V6 engine in the middle of the vehicle. That's great for handling, but challenging for heat.
The orientation itself is roughly 20 degrees from the front of the wheel. So you get very clean, fast air straight into the high temperature radiator, and you enable the cooling of what is quite a hot powertrain. It might look like just quite a decorative line, beautiful sculpture if you like, but it's actually very, very purposeful.
Supercar style that evokes nature's perfect design.
Now, the surface itself, for me, it's one of the highlights. It's actually an oddly nice thing to touch. It's very much inspired by sand dunes.
Sand dunes inspire the shape of the car's surfaces, yet the direction air flows is anything but natural.
And the V6 hybrid creates an absurd amount of heat. So what we needed to do is get all of this hot air out as directly as possible, without sacrificing the aerodynamic performance on the car.
To move the hot air, designers come up with a curious solution. They add a chimney.
Most engines release a good amount of heat on the sides. The V6 powertrain, all the hot air just fires up through the chimney. You could use it probably as a fantastic barbecue, though I wouldn't advise to.
The chimney helps release the hot air. There is still a problem. How to move it out of the way.
These flying buttresses, they pick up air from here, free stream fast air, guide it inboards, and essentially start to pull air out of this area above the engine straight backwards.
The Artura's aerodynamic performance makes it the most fuel-efficient McLaren ever made. And part of the reason comes down to a very earthly material. McLaren's carbon fiber expertise is the stuff of legend. On March the 5th, 1981, they revolutionized Formula One with the debut of the MP41. It's the very first F1 race car to use a carbon fiber chassis.
It was the first time that we had introduced a carbon fiber monocell, or the safety cell, into Formula One.
The strong and lightweight material helps driver John Watson win the British Grand Prix. Yet it's a horrific high-speed crash that same season, which proves the newfound tech's mettle once and for all.
When he crashed that year, people were so shocked that he managed to walk away from the crash.
The monocell not only saves John Watson's life, but it also changes racing forever.
Every single Formula One car is followed in the carbon fiber world.
Today, most supercars harness the power of composites. To keep their edge, McLaren doubles down on its carbon fiber know-how.
We decided that we would now design and manufacture our own composite tub.
In 2018, the marque invests £50 million to open the McLaren Composite Technology Centre in Sheffield, England. While the facility is state-of-the-art, the location it calls home harkens back to another era of British manufacturing.
I mean, Sheffield has a very rich heritage in steel manufacturing. As you went through sort of the 80s, 90s, it became a situation where there was more unemployment, there was a closure of some of those industries, so it had some challenging times.
Today, Sheffield is climbing out of its post-industrial past thanks to companies like McLaren.
That we're now seeing a resurgence of new high-technology projects coming up in the city.
When the marque decides to set up shop, they face an immediate challenge: how to manufacture their new monocell chassis.
When we developed the technology, that was great, but we didn't have the equipment and machines to actually produce at the volume, so we had to design those machines.
Today, over 120 people call the 7,000 square metre facility home, and their focus is finding a way to manufacture state-of-the-art carbon fibre monocells faster than ever before.
Big focus of this particular project has been upscaling the volume that we can produce carbon fibre chassis.
The new monocell is important. It's not only the basis of the Artura, but will also underpin every subsequent vehicle for the next decade.
So the way we produce the carbon fibre chassis here is probably a little different than some people do it.
The process begins at an advanced cutting station.
And we've got large rolls of carbon fibre. It comes into the factory in about half-ton rolls of material, and then we cut that material here into the individual plies.
Each carbon fibre monocell is made from nearly 600 different shapes.
The operation here uses a very fine blade, and that's cutting through the different layers of carbon fibre. It's a real tough operation for this machine.
Once the pieces are cut, they're sent to the stacking section, where technicians start layering the material together.
The chassis can vary from 3mm to 20mm in thickness, so we lay up the different pieces here according to that.
Each part of the carbon fibre tub is a different thickness. Yet they all make their way through the same mega machine.
This is a three-dimensional forming process, and this is what really gives the initial shape to the chassis.
The three-story tool is bespoke, and how it works is a trade secret. Its speciality is how fast it can transform a pile of layers into a three-dimensional shape.
McLaren isn't just competing in road cars. McLaren is competing in Formula One. And every tiny little advantage that McLaren can eke out will pay huge dividends. So of course they're not going to let those secrets out. That tells me that the McLaren Artura directly benefits from what McLaren's learning in racing.
The finished parts are then sent to an injection station.
All the dry pieces are held together while we inject resin into the process.
The aim of the new chassis is to help the marque grow, and the key to that strategy is speed.
Particularly when you look historically, carbon fibre chassis will be handmade, and that would take something like 4,000 hours. You probably only do 2 or 3 chassis a week. The processes we've developed here are very automated, and that means we can make a far higher number of chassis in the time that we need.
When a fresh chassis leaves the resin injection station, a pair of technicians refine it by hand.
The machining tolerances be down to sort of 20, 30 microns, which again is pretty spectacular when you consider the size of the structure that we're working with.
30 microns is roughly half the thickness of a human hair.
So after all the finishing operations and all the final inspection stations, these products will be to get shipped down to Woking, where we build supercars, and these will all start to be the foundation of all those new cars.
Each day, 20 brand new chassis leave the Sheffield facility and head directly to McLaren's Woking site, where it will take another 2 weeks to transform them into brand new vehicles. The Artura is the first in a new generation of supercars. Costs £189,000 and is only the second car ever made by McLaren Automotive from a blank sheet of paper.
McLaren's a really unique British supercar, and I think our successes have been that we still don't have a great deal of product out in the world in comparison to our competitors.
In little more than a decade, McLaren has produced just over 25,000 vehicles, making them one of the rarest supercars on the market. And every single one has come from Woking, England.
We are in the McLaren production centre, and what we've tried to do here in Woking is make it feel more like a showroom. You can see just how bright and clean and pristine that it is.
It's not easy keeping a 33,000 square metre facility looking immaculate. And they do almost everything under just one roof.
We've got body assembly here, we've got paint over there, and we've got general assembly right here.
Roughly half of the space is dedicated to the paint shop, while the majority of the rest is the final assembly line.
What's keeping us most busy right now is Artura. A real step for us, both in terms of the product itself, because it's a very special product, but it's also a level of sophistication in a manufacturing sense.
A sophisticated challenge that combines hardcore scientific advancement with craftsmanship.
If this was Wembley Stadium, we're in the grandstand here, and we're looking at the players who are our men and women down there on the floor. The important part of winning a football match at Wembley is those guys down there.
The build process begins when monocells from the Sheffield carbon fibre factory enter the body assembly line.
So here we are at the beginning of the process, the genesis of the car. And as we start to build an Artura, life starts here. We're loading what we call in the factory the tub, and the rear frame is what will do the marriage, the line-up, and make sure that's perfectly set.
Setting the foundation just right is vital, and the tolerances are precise.
Body fits and shuts are normally measured in fractions of a millimetre, so 0.1 of a millimetre. Less than that, the naked eye can't spot it.
The body sides go on. The roof is added. And soon, the advanced carbon fibre chassis looks like a car.
Start to add parts step by step until we get to the far end when we can recognise a body.
The built-up bodies then enter the paint shop, where one of 60 colours will be applied. Unlike other car factories, everything is done by hand.
We are all manual paint. The skill required is some of the highest in the factory.
Manual work that turns bare bodies into colourful sculptures.
So here we are at the beginning of general assembly.
The General Assembly Hall features 33 stations that cycle every 43 minutes. It's a slow way to build a fast car.
We have no automation. The team members will pick up the car and literally manually shuffle it along.
The first half of the General Assembly line is purely mechanical. And the most exacting station is the marriage. This is where each new Artura receives its V6 engine.
The space it goes into is extremely well optimized. And that's the knack that we have to have.
After the ceremony, partially built cars turn around and head back down the second half of the line, where mechanics install the bits of kit you see and touch.
It's taken us 10 days or 2 weeks to get to this point.
Every day, 20 new cars roll off the line, including the Marque's newest hybrid. A vehicle that's 59% more efficient than the car it replaces, and the most eco-sensitive McLaren ever.
We're not afraid of the future, not afraid of change, and we choose the technology that's most appropriate for the job, whether that's to comply with the regulations in motorsport categories or to deliver the best driving experience.
The Artura, the Marque's first series production hybrid. A bold look into the brand's future. And perhaps the most important supercar that McLaren has ever made.
As we evolve in propulsion systems, we will stay very focused on power to weight, a very engaging experience for the driver.